Evaluate this triple integral of 1 over square root of 1 minus x square minus y square minus z square dz dy dx. Z is having the limits from 0 to square root of 1 minus x square minus y square. Y is having the limits from 0 to square root of 1 minus x square, and x is having limits from 0 to 1. So we have to evaluate this triple integral by changing to spherical polar coordinates. So the region of integration is bounded by z equal to 0 and z is equal to square root of 1 minus x square minus y square, y equal to 0 and y is equal to 1 minus x square root, and x is equal to 0 to x is equal to 1. This is nothing but the volume of the sphere x square plus y square plus z square equal to 1 in positive octant. This is your positive octant of the sphere. And then for spherical coordinates, we write x as, yes, r sine theta cos phi, and y is r sine theta sine phi, and z is r cos theta. So that x square plus y square plus z square is equal to, when you square all these and add, you will get if this is equal to r square. Please look at this figure. For positive octant of sphere, the limits for r varies from 0 to a. Sorry if it's not clear to you. And the limits of theta is varying from 0 to pi by 2. And for phi, the limits are varying from 0 to pi by 2. And then it is given for the hemisphere. That is not required, just the first one. So for the volume of the sphere, x square plus y square plus z square equal to 1 in the positive octant, as x square plus y square plus z square is equal to r square, and for the volume of the sphere, this x square plus y square plus z square is equal to 1. So the limits of r is varying from 0 to 1. This is your 1. So r is varying from 0 to 1. Theta is varying from 0 to pi by 2. And phi is varying from 0 to pi by 2. And now solving this integral, putting the limits for r, theta and phi, and writing the integrand in terms of the spherical polar coordinates. So before putting the limits, I'm going to write the integrand. So this is 1 over square root of 1 minus, this is x square plus y square plus z square, that is r square. And we multiply with r square sine theta according to the formula dr d theta d phi. So for spherical polar coordinates, we write r square sine theta with dr d theta d phi. And now putting the limits for first r, that is from 0 to 1, and for theta is 0 to pi by 2, and for phi it is 0 to pi by 2. First, solving this innermost integral. So this is 0 to 1. I'm having in the denominator 1 minus r square. So let me add and subtract 1 so that I can get 1 minus r square in the numerator. So I'm adding 1 and subtracting 1. With this minus r square, I can write like this. Is it fine? If you open this, you will get as your r square only in the numerator. So this is 1 minus r square square root, and this is sine theta dr d theta d phi. And then I'm going to separate this 0 to pi by 2, 0 to pi by 2, 0 to 1, 1 over square root of 1 minus r square, and this is 1 minus r square over square root of 1 minus r square. That will give you 1 minus r square with square root in the numerator. Sine of theta dr d theta d phi. And then this is equal to 0 to pi by 2, 0 to pi by 2. Writing sine of theta first because we have to integrate with respect to r, so sine theta is constant for this. What is the integration for 1 over square root of 1 minus r square? It is simply sine inverse r, and integration for square root of 1 minus r square is r by 2 square root of 1 minus r square plus 1 by 2 sine inverse r. So writing the first integral is sine inverse r, and then the integration for this square root of 1 minus r square, this is r square root of 1 minus r square over 2 plus 1 by 2 sine inverse r, and limits from 0 to 1 d theta d phi. So when you put 1 over here, you get pi by 2. When you put 1 over here, you get 0, and from here I get 1 by 2 into pi by 2. So this is negative sign is outside, so that is negative 1 by 2 into pi by 2. And minus, when you put 0, here it becomes 0, then this is also 0, whole thing is becoming to 0. So this is d theta d phi. As this is your constant 0 to pi by 2, this is what? Pi by 2 minus pi by 4, which will give you pi by 4. And integration for sine theta is negative cos of theta, and then the limits d phi. So taking pi by 4 outside with 0 to pi by 2 integral. Okay, what is cos of pi by 2? That is 0 minus cos of 0 is 1, and because I'm having negative sign also, so this will become positive 1 d phi. So this is equal to pi by 4, and integration for 1 is phi, and the limits from 0 to pi by 2. So this is equal to pi by 4 into pi by 2 minus 0. That is equal to pi over 8. Pi square over 8. Yes. So this is the answer for this integral. Please note over here, for whole volume of the sphere x square plus y square plus z square equal to a square, r will vary from 0 to a, and then theta is varying from 0 to pi, and phi is varying from 0 to 2 pi. Please note this. Alright, thank you. Stay blessed.